Hello friends, good morning, good afternoon and good evening. So we are going to learn today Kirchoffs voltage law. So Kirchoffs voltage law says that for a given loop, the algebraic sum of voltages is always zero. So for example, we have drawn a circuit here. It has two batteries, three resistors and two loops, as you can see, loop 1 and loop 2. So before going to Kirchoff's voltage law, let's write an equation for Kirchoff's current law, right? So what does current law says? Sum of currents entering into a junction. So here this is a junction. So sum of current entering into junction is equal to sum of currents leaving out of the junctions. So for this one, if you see entering current is I1, so I1 is equal to currents leaving out of the node, which is equal to I2 plus I3. Yeah. So now, while writing an equation for Kirchoff's law, two things are very, very important. One is how to write the polarity of a battery if you are following like the clockwise in this loop one. So if it is minus and plus, then you consider this as plus. And if you are going in a loop where first sign comes or first battery terminal comes as positive, then you take it as negative. It's as simple as that. Or in short terms, if it is like this, then negative. If it is like this, then positive. And another thing you have to remember is V equal to I into R. Yeah. So let's try to write the equation for loop 1. So here is loop 1, loop 2. We have marked current this as I1, I2 and I3. So since we are following this loop, so and the first terminal comes as negative and positive. So if you see here negative and positive, then we have to write it voltage as positive. So I have written as 10, then minus. Why minus? Because we have written the polarities, right? The current is following in that direction, so polarity for resistance is plus and minus, plus and minus, plus and minus. So V is equal to I into R. That's what we written here. So by same formula, we are going to write minus 2 I1. And we are following loop 1. Here it is again plus minus resistance, then hence minus 3, which is resistance value, and current following in this branch is I2, so that's why it's minus 3 I2. So this is what the Kirchoff's voltage law for the loop 1, and you can replace I2 by I1 minus I3, which came from the Kirchoff's current law here. I1 is equal to I2 plus I3, hence I2 is equal to I1 minus I3. Similarly, if you want to write Kirchoff's voltage law equation for loop number 2, how you are going to write it? Start from here, like V equal to I into R. Since this is in the direction of current, plus and minus, so minus 4 I3, which I have written here, minus 4 I3. Then here if you see, battery is first plus and then negative. So what we have written here, positive and negative. If it is positive and negative, then write it as negative. Hence minus 5, the battery value. And then for this one, since the polarity is negative and positive, we will write it as plus 3, current is I2. Again, you can replace I2 by I1 minus I3, and that will make the equation as minus 4 I3 minus 5 plus 3 I1 minus 3 I3. And you can solve this equation. So Kirchoff's voltage law is very simple to understand, and you can write those equations the way I have written. Let me know if you have any doubts. If you want to learn any other laws of basic circuit theory, please message me in the comments. Thank you and have a great day.